Hey, what's up? It's your old pal, Mr. Cook. We're going to go through this Unit 8 Part 1 test review. Uh, Dang, looks like there's a bunch of pages on this. Well, whatever. So what do we got to do here? Identify the conic, put it in standard form, and then sketch it. Okay. So you got to be comfortable with, completing the square, and then also recognizing the different patterns. And also, when you're identifying conics, asking the three questions that help you to identify the conic. So yeah, let's do this one piece at a time. I'll do a brief little review on all these things, and then we'll kind of go from there. So first off, when you're trying to identify a conic section, you ask three questions, okay? And they're yes or no questions, and they're all about the conic section that you're working on. And let me see how many conics we're working with. Identify, standard, sketch. So 8 questions. Okay, so these 8 questions, we can do these real quick. All right, ready? So identifying the conic section. First question that you got to ask is, do you have both an x squared term and a y squared term? If your answer is no, then what you have is a parabola. It's that easy, okay? Just on that first question. So like number 1, I only have an x squared term. I don't have a y squared term. So I know for a fact that this thing is a parabola. It's that easy. Number 2, I only have a y squared. So again, this is a parabola. I don't have an x squared, right? Number 3 has an x squared and y squared, so I know it's not a parabola. Same thing with number 4. Same thing with number 5. Same thing with number 6. Same thing with number 7. Same thing with number 8. See, these are parabolas. The next question that I ask after that is, so let's say that yes, I have an x squared and a y squared, then I move on to the next question, okay? So question number 2. Are both x squared and y squared the same sign? And that means, are they both positive or are they both negative, okay? If your answer is no, then that means that you have a hyperbola. Excuse me. But if your answer is yes, then you go to question number 3, the last question. So let's see if we can spot any hyperbolas. So they have to have x squared and y squared. And they also need to have different signs. So number 3, they have the same sign. So I don't know anything about that. Same thing with number 4. Same thing with number 5 and number 6. But look at this, number 7. I have an x squared and a y squared, but one of them is negative and one of them is positive. So that means that I know for a fact that this thing is a hyperbola. And same thing with number 8. My x squared is positive, my y squared is negative, so that means that this is also a hyperbola. And then the last question that you need to ask is as follows. So we already know that we have both an x squared and a y squared. We already know that they have the same sign. So the last question is, your x squared and y squared term, do they have the same exact coefficient? If your answer is no, then that means that you have an ellipse. If your answer is yes, then that means that you have a circle. That's it. That's the 4 different types of conic sections that we have. So let's take a look at number 3. Oh, well, yes, the x squared and y squared are there. They both have the same sign, and they also have the same coefficients. So that makes this a circle. Number 4, x squared and y squared exist. They both have the same sign and the same coefficient. This is also a circle. Number 5, the x squared and y squared exist. They both have the same sign, but they have different coefficients. That makes this an ellipse. Same thing with number 6. The x squared and y squared exist. They have the same sign, but different coefficients. So an ellipse for this one as well. All right. So now that helps with the identifying part. So hopefully you've mastered that. It's just based off these 3 questions, and that's it. So identifying the conic is all done. Next, what we want to do is put the equation into standard form. So standard form means that it's all like factored out and stuff, okay? So what you need to do for that is complete the square. I'm going to already assume that you know how to complete the square. If you don't, Well, I got great news for you. There's this thing called, have you ever heard of YouTube? Right? YouTube. It's this like website. It's brand new. It has all these like videos on it. Well, actually, it's been around for like a while, I guess, but it's brand new to me. And you can do a search on it and look up a phrase like complete the square or learn how to complete the square or complete the square for conic sections. And you get like this full lesson, and you can watch those videos at like 2.5 speed or whatever you can handle and learn how to complete the square of these things. I'm going to assume you already know how to do that. Otherwise, go watch a video on it, okay? But let's say that you do know how to complete the square. Then once you've identified the conic, all you have to do is complete the square for the x variables and for the y variables, if there's a square to be had, and you can turn it into standard form. So here's how the different standard forms look. So for a parabola, it can look one of two different ways, okay? So a parabola that's facing either up or down is going to have x squared. So it'll look like this. It'll be x minus h squared, so a completed square, is equal to 4 times p times y minus k. X minus h and y minus k is going to feature in every one of these standard forms. H and k represent either the center of a circle or an ellipse or the center of a hyperbola. In the parabola's case, it represents the vertex. Now, this is for a parabola that either faces up or down like this or down, okay? But if you want it to face left or right, you just make the y values squared instead. So it's going to be y minus k squared equals 4p times x minus h. And that's either going to open to the left, a parabola open to the left, or a parabola that's open to the right. And you can like tell which one it's going to be based off of this coefficient that's out front, okay? So if this value is positive, it's some positive number, and it's an x squared, okay? It'll be facing upwards. If it's negative, it'll be facing downwards. If you have a y squared instead, remember it's either going to be left or right. If that 4p number is positive, it's facing to the right. If it's negative, it's facing over to the left, okay? So that's just good stuff to kind of know to anticipate what the graph is going to look like. Okay, so these are the standard forms for these. And then let's see, then we have the ellipse. So for an ellipse, it looks like this. It's only one form. It's x minus h squared over a squared plus y minus k squared over b squared. And then that's equal to 1. And then you've also got a circle. So the circle standard form looks like this. It's x minus h squared plus y minus k squared equals the radius squared. I'll wait for that to show up. There we go. And then the last one is the hyperbola. So for a hyperbola, it looks like this. It's very similar to the ellipse, x minus h squared over a squared. And then minus, though, y minus k squared over b squared equals 1. And then the other one is, if you switch it around, so you make the negative on the x value, the squared x. So the first one where you have the positive x squared, that's going to be a hyperbola that opens to the left and to the right. And then when you have a positive y squared, and that means it's going to open up and down like that. And I'll show you how to graph those pretty easily, when we come to them. Anyways, so for a parabola, I've just got to make it look like this. So I'm going to complete the square and all that stuff with it. All right, here we go. So standard form for number 1. I got to complete the square. So I complete the square with this stuff. So I group the x's together. And so that'd be x squared minus 6x. Then I've got this other stuff, minus 8y minus 7 equals 0. And kind of look what you're trying to make it into. If the x is squared, it's going to look like that. Okay, it's like the top one. And so I need to make that, just that perfect square on the left-hand side, and all the other stuff on the right-hand side. So I'm going to move all this stuff over to the right-hand side. Okay, so I'm going to add 8y and add 7, and here's how it ends up looking. So just like that. Okay, now I'm going to complete the square on this side. So if I complete the square on this side, what I do is, you watch the video on it, right? So all you have to do is just divide that number by 2. So you get x minus 3. That's your perfect square. And then to adjust for the additional amount that you add on for completing the square, in this case, it's just going to be negative 3 to the second power. So 9, I'm going to add the 9 over here, just keep it equal. Okay, and then after that, 6 and 9 add up to 16. Or sorry, 7 and 9 add up to 16. And we're pretty close. We just got to get like this part. So I've got to factor out an 8 from both these terms. So I get 8 times parentheses y plus 2. Okay, there it is in standard form. And, now that I have it in standard form, I can graph it real easily. So I'll do that in a second, okay? I'd first like to get all of these in a standard form, okay? So I'm going to go through the next couple questions and get them in standard form. So similar to this, I'm going to group the y values together. So y squared plus 2y plus 16x minus 63. I'm going to group those. And then I'm going to move this stuff over to the other side. So I get, let's see, a negative 16x and a positive 63. Okay, now I'll complete the square on this stuff. So I'm going to divide that by 2. So I get y plus 1 quantity squared is equal to negative 16x plus 63. And then I'm going to add on, let's see, 1 squared. So add on 1 to both sides. So I'm going to add it over here. There we go. And then 63 and 1 gives me 64. Okay, I'm almost done. All I got to do is just factor out that lead coefficient. So if I factor out negative 16 for both of these numbers, I would get negative 16x. And then 64 divided by negative 16 is a negative 4. So there we go. Now it's completely in standard form for conic section that is a parabola. Okay, and then number 3. So same thing. I'm just going to group the x's and group the y's. So 3x squared plus 12x plus, and then it's going to be 3y squared plus 18y plus 12 equals 0. I'm going to group the x's and group the y's. So I divide out the lead coefficient or any common multiples. So I'm going to take out 3 from both of these. So I get 3 and then x squared plus 4x. Same thing with the other one. I'm going to divide out 3. So 3 and then it's going to be y squared plus 6 y and then plus 12 equals 0. Then I'll complete the square here. So I get x plus 2 squared. And complete the square here. So I get 3 and then y plus 6 divided by 2 is 3 squared. And then plus 12. And then to keep things equal, I need to remember multiply that extra factor out. So I get 2 squared 4. And then I got to also multiply that by 3. So the number that I'm adding on here on this side is 12 technically. Because again, 2 squared times 3. So I get 12. So I'm going to add 12 over here. So 0 plus 12. And then on this side, on the other one, I'm going to get 3 squared, which is 9. 9 times 3 is 27. So I'm going to add 27 on this side over here. Okay, and then we're almost done turning this into a circle. Next, I would subtract 12 from both sides. So 12 is gone. So that leaves me with just 27 now. Let me make this look a little bit nicer. There we go. And then the last thing is, notice that in the circle, there's like nothing in front of there, right? So I'm going to divide out the 3 from both sides. So if I divide out 3 from everything, divide by 3, and then 27 divided by 3 gives me 9. So this turns into a 9. And there it is in standard form. And that's going to be really easy to graph in a little bit. Okay, number 4, same steps. So let's see here. Group the x's together. Group the y's together. Divide out the common coefficient. So we have 2 and then x squared minus, then it's going to be 8x plus 2 times parentheses y squared plus 2y plus 24 equals 0. Now we'll complete the square here. So we get 2 and then that's going to be x minus 4 squared and then 2 and then y plus 1 squared. And then how much do we add on? Well, it's going to be 4 squared, so that's 16. 16 times 2 is 32. And then 1 squared, 1 times 2 is 2, so plus 2. Okay, next. Divide everything. Oh, wait, actually, sorry. Let's see, we're going to add this together, so we get 34. And then subtract away 24 from both sides, so we get 10. And then divide everything by 2. So we end up with a 5 over here. Okay, there's my circle. All right. Next up, we got these ellipses. So same steps, group together. So 9x squared plus 18x plus 4y squared minus 16y minus 11 equals 0. Factor out the coefficient, so 9 times parentheses x squared plus 2x, plus, and then divide out the 4, and then it's going to be y squared minus 4y minus 11 equals 0. Complete the square. So 9 times parentheses x plus 1 squared, 4 times parentheses y minus 2 squared. And then let's see, what numbers do we add on? So it's going to be 1 squared 1 times 9, 9. And then 2 squared 4, 4 times 4 is 16. Okay, and then let's see here. So then we also have to, I guess, add over 11. So plus 11. What's that total going to be? Goodness gracious. So let's see here. 9 and 16 is 25. 25 and 11 is 36. So we get 36 on here. And then the interesting thing about an ellipse is that this all has to be equal to 1, right? For an ellipse, where is it? Right here. Always equal to 1. So the last thing is just divide both sides by 36. And then you'll get the 1 on one side. See, watch. Divide by 36, divide by 36, divide by 36. So 36 over 36 is 1. And then 4 and 36 are both divisible by 4, so that turns into a 9. 9 and 36 are both divisible by 9, so that turns into a 4. And there's our ellipse in standard form. Similarly, you just do the same steps here. So 2x squared plus, minus 20x plus 50y squared plus 300y, oh my, plus 450 equals 0. And factor out the 2, so 2 and then x squared minus 10x plus 50 y squared plus, oh gosh, 300 divided by 50 is 6, so 6y plus 450 equals 0. And then let's see here, complete the square, so 2, and then that'll be x minus 5 squared plus 50, and then it'll be y plus 3 squared plus 450 equals, and then let's see, 5 squared is 25, 25 times 2 is 50. And then let's see, 3 squared is 9, 9 times 50 is 450, yeah, 450. And then subtract 450 from both sides. So that just canceled out the 450s, so it's just 50 now. And then let's turn that into a 1. So we're going to divide both sides by 50. Okay, so 50 over 50 is 1. And then 50 over 50, that cancels out. But let's leave a 1 down here, okay? Because that's going to help us out. Because remember, we need like something in the denominator. And then 2 and 50 are both divisible by 2, so that turns into 25. So this is the standard form for this ellipse. Okay, and then 2 more, and we're done with the standard form. I think that we'll end this video at standard form, then we'll graph afterwards. Okay, so we get 4x squared plus 16x minus 9y squared plus 54y minus 101 equals 0. So then group them, and then divide out the common factors. So 4x squared plus 4x, and then divide out negative 9 from both of these. So we get negative 9y squared minus, minus, and then it should be 6y. And minus 101 equals 0. Okay, and then complete the square. So 4, and then it'd be x plus 2 squared minus 9, and then that'd be y minus 3 squared equals 101. Oops, sorry. Minus 101 equals 0 plus, then 2 squared is 4. 4 times 4 is 16. And then 3 squared is 9. 9 times 9 is 81. But this is a negative 81. Okay, so we're going to add a negative 81. That's because of this like little minus sign right here. Okay, and then let's see, what do we do from there? So next, we're going to add over 101 on both sides. And let's see what number we end up with here. Goodness gracious. All right, so 101 minus 81 is 20. And then 16 and 20 is 36. Okay, so this isn't that bad. And then we just divide both sides by 36. Okay, and then we simplify and all that. So that's going to be a 1. And then 9 and 36 are both divisible by 9. That leaves 4 in the denominator. 4 and 36 are both divisible by 4. That leaves 9 in the denominator. There's standard form for hyperbola. And one more. So group the x's, group the y's, and then factor out the coefficient term. So if I factor out a 9 from that one, I get x squared minus 6x. And then if I factor out a negative 25, I get y squared plus 2y plus 281 equals 0. And then complete the square, so 9, and then x minus 3 squared minus 25, y plus 1 squared plus 281 equals 0. And then let's see what we have to add on. So that's going to be 3 squared times 9. So 9 times 9, 81. And then let's see here. 1 squared is 1. 1 times negative 25 is negative 25. There we go. And then I'm going to subtract 281 from both sides also. Negative 281. And then let's see. So what's that going to end up being? Well, negative 281 plus 81 is negative 200. The negative 200 minus 25 is negative 225. And then I just divide both sides by negative 225. Okay, there we go. So that turns into a 1. And then a negative over a negative is a positive, so that's going to turn into a plus. And then let's see here. 25 and 225 are both divisible by 25. That's going to be, 9? Yeah, just 9. Okay, so 9. And then 9 and 225 are both divisible by 9, so that'll be 25 in the denominator. And then since the denominator was negative and the numerator was positive, that turns into a negative now. Okay, there we go. So there's our other hyperbola in standard form. Okay, that's all I'll do for this video, just because I don't want it to be like, 7 hours long or whatever. And then the last video, or the next video, we'll just do graphing. So I'll see you in that video. Okay, I hope you found this helpful. If you didn't, go find your math teacher. I'm Mr. Cook. I'll be available in the morning to help you out if you need some help, or after school if you need some help. So come and find me. I'd love to help you. Okay, that's it. See you in the next video. Bye.